rest.
It's
Never remember. Rest
It's literature.
Thank you. Loquitur, yeah, that those two terms. I think those are the first couple of slides. The rest of it, if you guys don't know patient care right now, you're in the wrong field. Okay? Then the next 3 PowerPoints, data collection, image encoding, and case space, which is what we went over this week and last week, which has to do with the spatial encoding gradients, the physical gradients. What are the physical gradients? X, Y, and Z, which correspond to sagittal, coronal, and axial. The spatial encoding gradients. First one, slice select. Second one, phase encoding. Third one. Then you must know when they are turned on. Okay? Case space. 2 axes. Phase, which is vertical. Frequency, which is horizontal. So when we're talking phase, we're talking about top and bottom. We're talking about horizontal or frequency, left and right. Left half mirrors the right half, top mirrors, bottom mirrors the top, they mirror each other. Steep phase encoding slopes. What kind of signal?
Low signal.
Low signal. What is it good for? What is that low signal good for? The phase encoding, the steep phase encoding slopes is low signal and what lines of case space? Outer spatial resolution. Shallow phase encoding slope. High signal. Center of case space contains contrast data. Frequency encoding gradient. What is important about the frequency encoding gradient? It contains the image, it contains the long axis, the information for the long axis of the image, but what else? Frequency encoding gradient. What about the slope of the frequency encoding gradient?
Constant.
It's constant, it never changes. Why does the phase encoding change? Why does the distinctness of it change? To fill different lines of case space. Remember, all lines of case space must be filled in order to get image formation. This PowerPoint, this last one, pretty much to sum it all up, the steepness of the slope of the phase encoding gradient determines what type of signal, okay? I think on 6 different slides, it said the same thing. I'm just trying to beat it into you guys, okay? Steep phase encoding slopes, low amplitude, outer lines of case space, spatial resolution. Shallow phase encoding gradient. High signal. Center of case space. Contrast resolution data. Matrix. We have a phase and a frequency matrix, correct? What do those numbers correspond to? Pixel size, pixel. The number of pixels determines the size of the pixel. How's that? Does that sound better?
Yeah.
So if I have a 512 matrix, 512 pixels, what size are my pixels? What does that do for our image? Higher spatial resolution, why? What is the definition of spatial resolution? It's the ability to distinguish 2 points, right? So the more pixels you have in there, I always revert to, I mean, this book, this is the 5th edition, I believe?
No.
Fourth, okay. I have the 1st edition. That example is still used. The picture of the woman with, let's say, 128 pixels, and it's very blurry, but it's high signal. Next to a picture with, let's say, 512 pixels, sharp. You can pick out every, detail in her face. Okay, when you look at the one that's only 128, it's like her eyes are kind of, elongated. You can hardly pick out her eyebrows. You just see like a mark there, okay? Then you do 512, and now that spatial, that resolution, that detail has increased, okay? Questions? Pretty straightforward test. 50, always 50 until the final will be 100. Just wait, next semester final's gonna be 200 questions. I'm getting you ready for the boards. Next semester's final is going to include from day 1 when we started in August all the way through. It's gonna be kind of a mock registry. It's gonna be a hell of a lot easier than the registry, but.
When is the first class?
First class,
Or next semester?
oh, January.
Wednesdays, right? 9.
9, not till the 9th.
This is all over. You're at 2.
Questions?